Ready? Hi, welcome to the soda can demo. Hello, welcome to the soda can demo. First, I have to get all of the ingredients ready. And I need an exact measurement of the copper 2 chloride dihydrate I'll be using. So I take the formula weight for this, which is 170.48, and I need a 3/4 molar solution. So I'm going to multiply by 3. I'm going to divide by 4. And I now know that I need approximately 128 grams per liter of this material. Off to the triple beam. Here we are at the triple beam. I need to get 128 grams, and I'm going to have to mass by difference. Right now, I have a beaker on the scale, and the scale is balanced at its mass. I have to add 128 grams. Approximately correct. Now I can see if I can get the beam to balance without making a mess. I think I'm going to make a mess. This is copper chloride, and it is this beautiful teal color. Please make a note of it because color changes become important during this activity. Let's see if we're balanced yet. There we go. Close enough. Okay. The 3 ingredients that we need for this are an aluminum can, our copper chloride, and water. This is a regular can that you might get a soft drink in. The major difference is this one does not have a label. It also does not have a top. In order to be able to use it, I need to be able to handle it. And so I'm going to hole punch a couple of handles, if you will. Take a glass rod and stick it through. Now let's prepare the solution. Remember, make note of the color. We have teal, and as I mix the copper chloride into the water, you'll notice that at first we get a limey green color that is then quickly replaced with this very pretty blue. One of the things that is noticeable when the copper chloride is dissolved in the water is that there's a change in temperature. The water that we used was at about 23.5 degrees Celsius, but upon mixing, it goes up to about 26.5. So we have an increase in temperature during a dissolving of a material into water. Okay, now we add the aluminum. This is very light, so we have to weigh it down so it will sink in the beaker, and I'm simply going to put regular water in it. So it's now heavy. And now we're ready for our reaction to begin. You're going to zoom in on this, yes? Here we go. It's easy to notice that there's a lot of bubbling going on. We have yet another color change. And if you look down here towards the bottom, you can see a reddish-brown material that is falling to the bottom of the beaker. We have to sit and wait and let this reaction progress for a few minutes. I'll check on the temperature. At this point, it's up to 30 degrees, and the temperature will continue to climb. the reaction's been going nicely. Check the thermometer. It's now up to almost 50 Celsius. What about the water inside the can? Remember, we started with water that was at approximately room temperature, and now I can see that this water also has been heated up to almost 50 Celsius, simply by being in contact with the materials that are reacting. I can stick my finger in the can. Ooh, that's warm, because that's just plain water. And here comes the very best part. The aluminum is gone. We can see right through to the water inside the can. And the challenge question for you to answer is, where did the aluminum go? Many of you probably don't know that every can has a plastic liner in it. The plastic liner is there to keep your food or your drink from touching the aluminum, because it can give food a bad taste. I have another challenge question for you. Companies that make cans do this exact same thing, but they put the copper chloride solution inside the cans as part of their quality control process. You might want to think about why they do that and how they know whether their cans are being made properly or not. So the solutions have been sitting for a little while. I want to show it to you again. Here's what's left of our aluminum can. And with a little bit more time, the liquid in the beaker would become perfectly clear. If you look closely, there's still a little bit of reaction going on. And we have this rusty, coppery looking material that's precipitated to the bottom of the beaker. And now what we're going to do is put everything up on the board. So get your colored pencils out. Let's make this look as realistic as possible. All right, this is what you just saw. We had an aluminum can. And we suspended it in a beaker of copper chloride. But remember, at the beginning, the copper chloride and the water were separate. We had a beaker of water. No laughing at my drawing. Ah. And we had some copper chloride. It was a tealy color, but I don't have that. So here were our ingredients: aluminum, copper chloride, good old H2O. And what have we got now? Well, we have a beaker and we have some copper oxide. In other words, rusted copper. That's the material that fell to the bottom. We have a beaker with a clear liquid in it. And then we have hydrogen with an up arrow. So we had bubbles that were released. I challenge you now to answer the questions that come after the reaction equation. Good luck. It's due tomorrow. I'll be checking it. Remember, you can watch the video over again if you're stuck. Maybe there's some clues in there. As a little added bonus, I saved this one from last year, and you'll notice that the aluminum is completely gone, and we have here this little plastic liner. Sometimes I'm tempted to poke the liner when it has the water in it, but this is really dangerous because I've done it a couple times and it breaks holes and then it just goes all over and makes a mess. So wish me luck. You see that? Isn't that cool? That is cool. And when it's all dry, it's just that. You'll never look at a can the same way again.